Hello, everyone. Welcome to the last section of Unit 4. Talk about complex numbers, and complex numbers are not probably what you think they are. We'll talk about what makes a number complex and kind of the role that it plays and kind of what we've been talking about with this big idea of quadratics and things. Okay, basically, what the idea here is this: for all of the quadratics, when we've been solving. Okay, we've been looking for zeros. Well, sometimes in a quadratic, I might have a situation like this where it never crosses the x-axis. So we might say that there's no solution. Up until that point, that would be fine. But now, with complex numbers, that is no longer the case. Okay, so the complex number we're going to be spending the most time with is I, and that equals the square root of -1. And we will kind of start to get to the idea of how and where square root of -1 or I comes into play. Okay, so a couple of ideas to remember about square roots. Okay, multiplication and division, you can separate underneath square roots. Same thing with division. Okay, so if I've got the square root of 36, I can split that up into 9 times 4. I can split that up into the square root of 9 times the square root of 4, which will just be 3 times 2, which will just be 6. Okay? Similarly, if I could take the square root of 20, that can split into 4 and 5. That can take into square root of 4 times square root of 5, so that will be 2 square root of 5. Similarly for division, if I've got the square root of 16 over 9, I can split that into the square root of 16 over 9, so I can just get 4 over 3. Okay, that's kind of how this one works. All right, another example is just say like the square root of 7 over 25, square root of 7 on top, square root of 25 on the bottom. That would be my simplified answer, okay? So, in simplified square roots, okay, no radicals in the denominator and no number underneath the square root that can be pulled out, okay? So no number, so none of this, no, you can't have 7 over square root of 11. Can't have that. You also cannot have square root of, let's just say, 20, because 20 can be split into 4 and 5. I can take the square root of 4, so I should get 2 square root of 5. Okay? So you have to make sure no number underneath the square root has a perfect square and no radicals in the denominator. So when I simplify square root of 50, I can do this a couple different ways. I would love if you recognized right away that that is the square root of 25 and the square root of 2. So then my answer is just 5 square root of 2. If you didn't recognize that right away, you're not necessarily, in trouble. Most kids would even without thinking realize I can split that into 5 and 10. You can, but you can keep going and go 5 times 5 times 2, then realize 5 times 5 and split that, and I get the same answer. Okay, so I'm not in trouble just because if I don't guess it right away. 45, most of you guys are going to divide by 5, so that's fine. So you're going to get 9 times 5. Square root of 9 times square root of 5 is 3 square root of 5. 128 is, most people are going to say, hey, I can divide that by 2, but that does us no good. I can split that into 4 and 32, and that's fine. But realize 32 can split again. Okay, so that'll just be 2. And then square root of 32 I can split again. I could split that into 4 times 8. So I can split that. And then 8, I can split again. So that's going to be 8 square root of 2. Or if I was really savvy with most of my square root things, I would recognize that that is square root of 64 times 2 and go directly to 8 square root of 2. So likewise, variables follow much of the same rules, okay? So this would be just x, okay? This one I will split into the square root of 25, the square root of x squared, and the square root of y to the fourth. So that's going to be 5. Square root and x squared cancel each other out, so that's just x. Y to the fourth is kind of like saying y squared times y squared. So that's going to be y times y, so that's going to be just y squared. There's my answer. F, before I even do anything with this, what I want to do is take simplified inside. So that's going to be like square root of x over 1. The square root of x over 1, which will just be square root of x over square root of 1, which will just be square root of x. So here, splitting apart, square root of 11 over square root of 49. So that's square root of 11 on top, 7 on the bottom. That's as far as I can go. Middle one, square root of 32 on top, square root of 81 on the bottom. Bottom is just going to be 9. Top, I need to keep going with the square root of 32. 32 can be split into 16 and 2, square rooted. So it's like square root of 16 times square root of 2 all over 9. So that's going to be 4 square root of 2 over 9. Last one, before I even do anything, I want to take 32 divided by 8, because that's just going to be 4x. Square root of 4 times square root of x, that will just be 2 square root of x. Something to note, if you actually do take square roots, it's not just the positive number, that's what everybody remembers. There's actually 2 solutions, and the negative one is going to be 1 as well. So now, solving, all right, solving for x. Yes, I can factor, but I want to do this by square roots. So add 25, square root. So x is going to either equal 5 or negative 5, or written like this. X equals plus or minus 5. So here, add 45, 2x squared equals 98. Divide by 2. Square root, x is going to equal plus or minus 7. This one, add 12. You get x plus 2 squared equals 25. Square root. So x plus 2 equals 5, or x plus 2 equals negative 5. Square root of 25. Let me write it somewhere else. Square root of 25 equals plus or minus 5. So down here, my answers are going to be 3 or negative 7. Over here, negative 48, 3x squared equals 48. X squared equals 16. Square root. X is going to equal plus or minus 4. Okay, just starting to get used to that idea. Now, Rene Descartes, that's how you say his name, figured out that you could have a number that I squared equals negative 1. Okay? Then what he figured out is that if that's the case, then I is going to equal the square root of negative 1. Okay? So for my example, this is supposed to be a 2. So 2x squared plus 2 equals 0. So subtract. 2x squared equals negative 2. Divide by 2. x squared equals -1, square root, x is going to equal plus or minus I, or square root of -1, okay? Plus or minus -1. So now where does this fit in the grand scheme of things? If I've got the set of all numbers, all right, in the Venn diagram below, here's kind of what it looks like, all right? In the smallest circle here, you're going to put natural. Okay, that's like 1, 2, 3. Then slightly above that, you're going to have whole numbers, which is all of the natural numbers plus 0. Then if I go one step further, I'm going to go integers, which is all of your negative versions of integers, of whole numbers. Then one step above that is going to be irrational. Okay? So irrational, 5 over 9, 0.3 repeating. Those are rational. All right? Down here in this circle by itself, you're going to have irrational. Okay? The big difference, these do not end and do not repeat. So pi, square root of 2, e, square root of 22 over 7. Those are all irrational numbers. Now, all of these numbers are still considered real. Okay? Now, if they're real, are the other ones non-real? And the short answer is yes. These are called imaginary numbers. Basically, anything that would have an I attached to it. Okay? Then outside of that, we have what's called complex numbers. Complex numbers are a combination of real and imaginary. So a complex number, easy example, 4i plus 3. Or, 2 plus 5i. Those would be considered complex numbers. So how do they work? So what I want to do is I want to split this into -18, or positive 18 times -1, because the square root of -1, I'm just going to rewrite as I. So now I have the square root of 18. That splits into 9 and 2. So that's going to be square root of 9 times square root of 2, so that's going to be 3. So this final answer is going to be plus or minus, because it's plus or minus 3, I square root of 2. There's my answer. Over here, this one, square root of 1, I'm going to bring out the -1, square root of 125 times x to the 5th. All right, so x to the 25th becomes 25 and 5. X squared, 1 pair, 2 pair. So I'm going to pull out 5. I'm going to pull out x squared. This becomes I, and I'm left with 5 underneath, x. Okay, I'm left with this 5 and this x underneath. There's my answer. All right, now when I do this, I can put these together. Okay? So this is like I times square -10, or positive 10, times I square root of 15. So I put the i's together. I put what's underneath together. So I squared is just going to be -1. This can split into 25 and 6. So I'm going to have -1 times 5 times square root of 6, or -5 square root of 6. Over here, I'm going to have -2 times 7 times I squared. -2 times 7, I squared is -1. So after all that, I'm going to get positive 14. Adding. In this case, I basically acts like a variable, okay? It's going to be 6 is going to go with 1. So I'm going to have 7 minus 4i plus 3i means I'm going to have 7 minus I is my answer. Over here, negative 2 minus a negative 1 becomes plus 1 minus 2i. So I'm going to have negative 1 plus 5i minus 2i is plus 3i. There's my answer. Foiling, or double distribution, whatever you want to call it, follows much of the same rules. So 36 plus 6i minus 6i minus I squared. But you know that I squared equals negative 1. So 36 cancels out minus a negative 1. So 36 plus 1 for 37 for an answer. Okay, let's skip to the last one. Base of parallelogram is half its height. The area of the parallelogram is 18, where the lengths of the base and the height of the parallelogram. So the base of the parallelogram is half its height. So h, 1/2 h. So h times 1/2 h equals 18. Okay? So this would be 1/2 h squared equals 18. So if I double it, h squared equals 36. So h is going to equal plus or minus 6. But I know that it's got to be positive because it's the length. So the height is 6, the base is going to be 3.